Okay, so if they're the power, if you multiply the powers, the bases are the same. So if you have like 2 squared times 2 to the 4th, and you are asked to simplify, that is 2 to the 6th. Same thing if you have a variable, x to the 5th times x to the 5th, for example, you would add your exponents, x to the 10th. Okay, if you are dividing and the bases are the same, you subtract the exponents. And you subtract the top from the bottom. So the numerator minus the denominator. The answer always goes in the numerator. So you do top minus bottom, put the answer in the numerator, and then simplify more if needed. So if you have like 3 to the 1st over 3 to the 3rd, the bases are the same. They're both 3. So we subtract the exponents, which is 3 to the 1 minus 3, which is 3 to the negative 2nd. We cannot leave that negative exponent. Remember, when we move it across the fraction bar, it changes the sign of the exponent. So our simplified version is 1 over 3 squared. And lastly, if we have a power taken to another power, we multiply the exponents. Whoops, multiply. So this would be something like x to the 3rd taken to the 4th power. We would multiply those exponents. So 3 times 4 would be x to the 12th. This also applies if there's a coefficient. So let's say we had something like 3x squared. When you have this in parentheses, you must distribute this exponent to both terms. So this becomes 3 squared, which is 9, times x to the 4th. Okay? Exponential expressions do not have an equal sign. So in the past, we maybe did these out of order. Simplifying, we're not solving for x. We're just finding the way to simplify the whole expression rather than finding what x equals. So number 1, x to the 3rd times x to the 9th. The bases are the same. So what should I do with the exponents? Add x to the 3 plus 9, x to the 12th. Number 2, the bases are the same and we're dividing. So what should I do with my exponents? Yep. X to the 10 minus 5, which is x to the 5th. Okay, number 3 is power of a power. What should I do with my exponents? Good. X to the 3 times 2, which is x to the 6th. Good. And then I'm going to give you one more. So put this one in there. Number 4, x squared over x to the 6th. The bases are the same. We're dividing. What should I do with my exponents? Subtract. What does this look like? X to the 2 minus 6, which is what? X to the negative 4. I can't leave a negative exponent. How do I make the exponent positive? You drop it beneath the fraction bar. So this becomes 1 over x to the 4th. And notice it only changes the sign of the exponent. It doesn't change the base. Bar changes the sign of the exponent only. Okay? So it changes the sign of the exponent from negative to positive or positive to negative. Whenever it crosses that fraction bar, the sign of the exponent changes. It does not change the power of the base. Only the exponent changes signs. You must always write powers with positive exponents. Otherwise, it's not simplest form. So always move it across the fraction bar to get a positive exponent. Okay? So if you have x to the negative 2nd, how would you rewrite that in simplest form? Drop it below, put a fraction bar, and drop it below. 1 over x squared. And then x to the 6th, how would I write that with a positive exponent?
X to the 6th over 1.
Yeah, just x to the 6th, which is x to the 6th over 1. But once we have it over 1, we can take away the 1. So that's it. How I like to do these is first by simplifying all the exponents, and then by doing my division with like terms. So first thing I should do here is get this power of a power simplified. And this 3 needs to go to both of the terms, or both of the pieces, the factors inside of that. So we'd have 3 to the 3rd. So on the top, nothing needs to be simplified. This one's fine. On the bottom, 3 to the 3rd is 27. And x to the 3rd would be x to the 9th. Once we're here, then I like to separate them, and I like to simplify things together. So like simplify my whole numbers, then simplify my exponents. 6 and 27 are both divisible by 3. So I get 2 over 9. And then with my x's, I have the same base, but I'm dividing, so I should subtract. 3 minus 9 is negative 6. The answer always goes in the numerator to start when you subtract. And then you simplify from there. So we are going to take just this part and drop it. The 2 is fine, so don't take the 2. Just drop that power that has a negative exponent to get it to a positive. So our final answer is 2 over 9 x to the 6th. And that's our final answer. All right, number 2, what's the first thing you should do? Yep, simplify the top. Give this 3 to both of the factors inside the parentheses. So we get 2 to the 3rd, which is 8, b to the 3rd, over 6b to the 5th. Then separate them. Simplify your constants, your coefficients. Both of these are divisible by 2, so I get 4 over 3. And then I can subtract, because my bases are the same. 3 minus 5 would give me b to the negative 2nd. And what's my last step?
Switch it to the
Good. Good. We're going to bring the b term below so that its exponent is positive. Don't move the 4. That's fine. We just move the b. So we get 4 over 3b squared. Okay? All right, let's try number 3. Yes?
Why isn't it 4 when you distribute the 3 to the b?
Yeah. So first I did 2 to the 3rd. You have to distribute that to the 3rd to the 2 as well. So you get 2 to the 3rd and b to the 3rd. 2 to the 3rd is 8, right? And then 8 over 6 simplifies to 4 over 3. You see that? Because they're both divisible by 2. Okay, let's do number 3. First thing I should do, should I give this in the denominator? Does that 2 go to the 4 and the x, or just the x? Just the x. So this becomes 12x to the negative 6th over 4x squared. Then I can just simplify my constants. 12 divided by 4 is 3. This is going to be in the numerator. And then I'm going to simplify my x's by subtracting. X to the negative 6 minus 2. Because I always subtract, I take the numerator and subtract the denominator, which gives me 3x to the negative 8. And then I have one more step because I have a negative exponent. I'm going to drop this below the fraction bar. The 3 is going to stay on top. So I get 3 over x, and then my 8 becomes positive once it crosses the fraction bar. Okay? Okay, last one. Okay, first let's simplify the top. This 2 is going to go to both the negative 3 and to the b to the 4th. So I'm going to have negative 3 squared. When I do this, it becomes this. Okay, when you square this, you do not square the negative. You only square the 3 and you put the negative on the outside. So 3 squared is 9, and that negative is on the outside. So we end up with, I'm going to erase that, negative 9 b to the 8th, right? Because 4 times 2 is 8. And on the bottom, we have negative 12 b to the negative 9th. So then let's start simplifying. Okay, let's start with our constants. If we, yes.
Wouldn't it be regular 9?
So because we're just going to give the 2 to the negative 3, it's going to be like this. If it was like this, then it would be regular 9. Because then I do negative 3 times negative 3. But when it's like this, order of operations says I do this first, and then I tack on the negative sign. Okay? All right, negative 9, negative 12 are both divisible by 3, and they're both negative, so it's going to be a positive answer. So I end up with 3 over 4. And then I can subtract my b. Watch what happens here. B to the 8th minus negative 9. So what ends up happening? We add. Oh. Okay, so we get 3b to the 17th over 4. And that is our simplified answer. Remember, what was the key when we were trying to solve exponential expressions? What did we have to get the same before we could solve for x? The bases. We also can simplify further if we have the same bases using our exponent rules. So if we have like number 581 squared times 1/9 to the 3rd, we could get these to all have a base of 3. Always go to the lowest possible base, and then we can put it all together in a most simple form. So we're going to rewrite each of these with a base of 3. So if we start with 81 squared, 81 is 3 to the 4th squared. And then, actually, I'm going to do this like this. Let's leave that with black. Times 1 over, rewrite 9 as 3 squared to the 3rd. Okay? Now, in order to make our math simpler, I'm going to bring this up. Right? I mean, actually, let's not bring it up. Let's leave it here. When I distribute this exponent, I give it to the numerator and to the denominator. Okay? And then I'm going to simplify. So 3 to the 4th to the 2nd gives me 3 to the 8th times 1 to the 3rd is still 1 over 3 to the 2nd to the 3rd would be 3 to the 6th. Right? Okay, now I'm going to do my multiplication. Multiplying straight across the top, 3 to the 8th times 1 is 3 to the 8th over 3 to the 6th. Now I've got the same bases, so I can just subtract my exponents. 3 to the 8 minus 6 would be 3 squared.
Didn't you just flip?
You could, yeah. So like that's what I would have done, but then I didn't know if that was going to be too much of a pain.
That was easier.
Yeah, because you just already have the minus 6, and then you just combine them.
-6 and then you just
Yeah, subtract. That's true. Yeah. We'll do another one like that, because that's how I usually do it. But I second guessed myself. All right, number 6. What base should we work with here on number 6? Good. Let's get a base of 2. How do we write 8 with a base of 2? 2 to the 3rd. To the x plus 2 times, how would I rewrite 16 with a base of 2? 2 to the 4th. Okay, here I need to distribute the 3 to both of those parts of the exponent. So I get 2 to the 3x plus 6 times 2 to the 4th. So remember, now I'm multiplying, which means I will just add the exponents. And the only like terms that I can combine are the 6 and the 4, right? Because there's no other x's that I can add. So my final answer is 2 to the 3x plus 10, because I add 6 plus 4. Okay, number 7, what should my base be? 5. So I'm going to rewrite 25 as 5 squared to the x plus 4. And then I'm going to rewrite 1 over 5 as 5 to the negative 1. I'm going to bring it up, because that's the same thing, right? 1/5 is the same as 5 to the negative 1. Distribute. So I get 5 to the 2x plus 8 times 5 to the negative 1. Now I'm multiplying. I will combine my like terms. So my final answer is 5 to the 2x. 8 minus 1 is plus 7. Okay? And last, what should my base be here? 3. So the top is fine, 3 to the 3x over 3 squared. To write this in simplest form, I can't actually subtract 3x and 2, but I can write it all as one term by saying 3 to the numerator minus the denominator. Does that make sense? Okay.